Okay, I think let's just get started with today's live session. So this would be the last live session summarizing all these lectures. And yeah, there might be one more session where I can just discuss some of your doubts that were like asked for in the previous week's class. I'll just prepare the solutions for that and I can discuss that in the extra live session. But yeah, today we'll just like go through the concepts that were covered in week 12's lecture of the course Essentials of Data Science with R Software 1. And yeah, if you had attended Saturday's live lecture by Shreya Chakraborty, the TA, this session would be a bit overlapping. Like, yeah, it's probably gonna be the exact same thing that she thought. So yeah, anyway, I'll just go ahead with it. And about the question of like file handling with R, yeah, we can just discuss that after we discuss this. You can just drop your email addresses as well. Like if anything, I can just write to you. Like if I'm planning to conduct anything extra. Okay, anyway. So yeah, week 12 was about testing of hypothesis, basics of hypothesis testing, and how you decide about your hypothesis. So like all throughout, so most of the classes, so like all throughout these lectures, we have learned about how you estimate the parameters. So ideally, you want your estimated parameter to be close to your actual population parameter. Uh, so yeah, so even hypothesis is to test that if your estimate is good enough to suit your hypothesis. Just give me a minute. Uh, Issues. I hope you can see my screen. Yeah, I think it's fine. So in general, when you do research, there's something that you expect it to be. Like, for example, you're testing a drug and you want the drug to have a particular effect on a disease or any condition, any scenario. So that in general, it's called your alternate hypothesis. And the drug having no effect would be your null hypothesis. So yeah, this is called the claim. The claim that you make is that your drug is going to be effective. So the claim is something that you want to believe in and you want that to be true for any given scenario. So yeah, so this is what null and alternate hypothesis is. Mm, Yeah, just all this. Yeah, I'm having a problem with sharing across my iPad and laptop. I'm not able to. Okay, so anyway, so like when you speak about statistical hypothesis, it is an assertion about the distribution of one or more random variables. So it tells us something about the random variables, whatever you estimate. So this hypothesis, which is basically your estimate of a parameter, can be simple or composite. So simple is when all information about the parameter is given. So let's say like you want to estimate mean. So mu is equal to 18. So in this case, all the information about the mean is given. So mean is exactly 18. But in case of composite hypothesis, it could be something like mu is greater than or equal to 18. So in this case, it could be mu can be 18, it could be 18.1, it could be 19, it could be 25, it could be anything. So this is just incomplete information. So this is called a composite hypothesis. That's the example that's given here. And this hypothesis testing can be either one sample hypothesis testing or two sample hypothesis testing. So it can be one sample or it can be two samples. And in two sample hypothesis testing, you can have either dependent samples or independent samples. So like a simple example of dependent sample would be, yeah, like you have a list of students. You have the same A, B, C, D students, but you have their marks in across different subjects in maths and in science. You have some marks. And this would be an example of dependent. And independent hypothesis testing would be you have a different list of students and their respective marks in maths and their marks in maths. So this would be independent. So like the information in this has nothing to do with the other set of information. So yeah, when you construct, so in hypothesis testing, the first step is to construct a decision rule. It's to construct a rule. So that is what you mean by this is that you have a sample space, and this is your region of interest, and like this is your region of interest, and this is the complement of the region. So this region could be called a critical region, and is usually your area of rejection of. So in this case, your null hypothesis is rejected. So yeah, you'll understand better when we see like examples. I hope you can see the correct slides. Yeah, some technical problem here. Okay, so there could be like four different scenarios. So one is something that is the truth that, and this is something that you hypothesize. So let's say like you consider a particular statement. The statement is actually a correct statement. And there are two scenarios for this correct statement. You can accept the statement or you can reject the statement. So when you accept the statement that is correct, your decision is correct. And similarly, when you reject the statement that is false, that is also your correct decision. But when you reject a correct statement, that is an incorrect decision. And when you accept an incorrect decision, incorrect statement, it is also an incorrect decision. So this is called type 1 error and this is called type 2 error. And the probability of type 1 error is given by alpha. It's called the size. And the probability of your type 2 error is given by beta and it's called the power. Yeah. And yeah, so this is given by 1 minus alpha, and this is also given by 1 minus beta. So these are just some things that you should remember. And the ideal goal is to reduce both these errors, especially type 1 error, because type 1 error is more dangerous than having a type 2 error. Like, for example, let's say a patient has a disease, but your test says that the patient does not have the disease. So that is more dangerous because the patient will not go through any treatment and the disease might actually kill him. But yeah, when the patient does not have a disease, but when you say that he has the disease, that should be fine. Like he will definitely like do some double checking, or he'll take medication, so that won't like uh be life threatening. But this type 1, the scenario that I mentioned first, that would be more life threatening. Just copy this. Yeah, it's all the same thing that is explained. Yeah, null hypothesis and alternate hypothesis. We saw about type 1, type 2 error. Okay, so let's learn about like how you test these hypotheses and how you arrive at the correct decisions and values. So like all throughout, we have seen about all these distributions, and we have some curve like this. So yeah, like you can see here, this shaded region is your region of rejection. Like if it's a two-tailed test, this region of rejection would be given by alpha by 2. And if it's a one-sided test, it's just given by alpha. And your region of acceptance is given by 1 minus alpha. So if let's say you have an actual value and you estimate a value which is given by t observed. If your t observed falls in this shaded region of rejection, that means that you reject your null hypothesis and accept your alternate hypothesis. But if the t obs follows in this acceptance region, you accept H naught. So this is like the basics of it. So yeah, so these are the scenarios where your test can be one-tailed or two-tailed. Sorry about that. Yeah, so these are scenarios where your test can be one-tailed or two-tailed. So like let's say your estimate is like a given number. That is your null hypothesis. So your alternate hypothesis is like mu is either greater than 14 or mu is less than 14. So this is two sides. So it's a two-tailed test. But let's say your null, oops. Yeah, just give me a second. Save. We were, yeah, so we were looking at this. And yeah, so if your null hypothesis this, your alternate hypothesis could be either of these. So it's a two-tailed. And if your null hypothesis says that mu is greater than 14, then your alternate hypothesis would be mu is less than 14. So this is just one-tailed. And even the other way around is also one-sided test. It's a one-tailed test. Yeah, I'm very sorry about this. It's just, I'm having a problem like annotating the file. Uh, yeah, so there's one more way that you could calculate. So one is by calculating your critical value and calculating your observed value based on the test statistics like F test or a Z test or anything like that. And the other way to determine whether to reject or accept your null or alternate hypothesis is by calculating a p-value. So p-value is basically the probability. Yeah, let me just take this. So p-value is basically the value of your alpha. So if alpha falls below 0.05 in general, you reject your uh, yeah, we're talking about p-value. So if your alpha falls below 0.05 in general, you reject your null hypothesis, reject H naught. So if alpha is above 0.05, you accept H naught. So alpha is basically the probability of like let's say like probability of your type 1 error is alpha, right? So type 1 error is probability that your statement like T is false given like I mean T is rejected given T is true. So yeah, let's just look at these in more detail when we solve the problems. Why does this keep going to this slide? So yeah, you could see in this table of the different types. So one case is where your population variance or population standard deviation sigma square is known. In that case, you estimate your mu, right? So in that case, you do a Z test, a normal distribution. So you use this formula that's given here. So all these formulas you will have to remember. And in the other scenarios where population variance or standard deviation is unknown, you have to estimate it with your sample standard deviation or sample variance given by S and S square. And you have to estimate your mean, which is mu. It's given by mu naught here. So in these cases, you'd use a t-test. And depending on the data that's given, you use like one sample t-test or a paired t-test or a two sample t-test uh, based on whether it's dependent samples or independent samples. So yeah, these are the formula that you should remember. And there's one more thing. And this so all the formula in the table, the tabular column that you saw, it was to estimate mu. But like you want to estimate sigma, you do hypothesis testing to estimate sigma square. So in that case, you do a chi-squared test statistic, and that is given by this formula. And the same thing, so this is not a symmetric distribution. And yeah, this is your critical region and acceptance regions. I'm so sorry. It just keeps going to that slide somehow. And yeah, there's one more kind of problems you would be given. One, it's testing the hypothesis for different variances. So you have like two different independent distributions and you have different variances. So the variances could either be equal or they could be different. So yeah, you have to test for the difference of the variances and you use this formula, you use a F statistic and you do this. So when the null hypothesis is true, yeah, this FC or estimated value would be equal to your F statistic. Yeah, it's all better like if we solve problems. Just keeps going to that slide. Okay. So this is the first problem. So yeah, the first problem is let x1, x2 up to xn be a random sample from a population with normal distribution. So it follows a normal distribution 0, 1 with population mean mu. So which of the following is not a composite hypothesis? So we saw that the hypothesis could either be simple or composite. So simple is when you have the exact value. So this is, you have your H naught where mu is equal to 5, you have your exact value. So this is a simple hypothesis. And all these are composite hypothesis. So like greater than 5 means it could be any value greater than 5, less than 5 could be any value less than 5, not equal to 5 could be any other value. So all this information is not definite. It doesn't tell us much, like it doesn't tell us exactly what mu is. So all these are hypotheses. So which of the following is not a composite? Option A is your answer. And the next question. So suppose an experimenter tests the hypothesis H naught. So your null hypothesis here. Yeah, so you have, so in null hypothesis, the probability is given by 0.8, and your alternate hypothesis, your probability, it's P, yeah, probability is given by 0.5. So this test hypothesis, it follows a binomial distribution n comma p. So in the question, it's given that based on 15 Bernoulli trials. So it follows a binomial distribution 15 comma p. So this p could be either 0.8 or 0.5. So what is given? The decision rule is to find the test statistic t as the total number of observed successes and accept, observe basically p, and accept the null hypothesis is t is greater than 11. So null hypothesis t is greater than 11. You reject your null hypothesis if t is greater than equal to 11. T is less than or equal to 11. So this is your null hypothesis, this is your alternate hypothesis. So you need to calculate the type 1 and type 2 errors. So type 1 error is basically the probability that T is less than equal to 11, given your alternate hypothesis H naught. So this means, what does type 1 error mean? You actually reject your null hypothesis, given your null hypothesis is true. So if you reject null hypothesis, yeah, it's basically probability of rejecting H naught, given H naught is true. Or in other words, probability of accepting H1, given H naught is true. So here H1 is T less than equal to 11. So you write probability of T less than equal to 11 given H naught is equal to 0.8. 0.8. So this can also be written as 1 minus probability of T greater than 11 given probability is equal to 0.8. So you can calculate this using your formula. For binomial trial, you remember you had the formula n choose x p power x 1 minus p power n minus x. So yeah, you can do that. You do it like this: 1 minus p of t greater than 11 up to 15, right? So this would be probability of t is equal to 12 given probability is equal to 0.8 plus probability of t is equal to 13 given 0.8 plus like probability t is equal to 14 given 0.8 plus probability of t is equal to 15 given 0.8. You can do this using this formula, or in R you can directly do it using 1 minus p binom, 11 comma 11 is your number of successes desired greater than 11. So 11 comma 15, 0.8. Let's look at this in R. Can you see my R window? So yeah, you can do it by 1 minus p binom. 11 is your expected number of successes, like greater than 11, so you write 11. And total number of trials 15, your probability 0.8. And lower tail is equal to false. Because you have a greater than sign. If you remember, we had t greater than 11. So because you have a greater than sign, you write lower tail is equal to false. So if you run this, you get 0.3581. So if you do this, you get lower dot tail is equal to false. So if you run this, you get 0.3518. So this is your probability type 1 error. So yeah, type 1 error. It could be either option C or option D. And now we calculate type 2 error. We had type 1 error. So type 2 error would be probability of accepting H naught given H naught is false. In other words, probability of accepting H naught given H1 is true. So you write it as probability of, what is probability of accepting H naught? T greater than 11. Probability of T greater than 11 given probability is equal to 0. What was the probability of H1? 0.5. Uh, 0.5. So you can do this the same way. You just have to do like P binom. Like previously we did 1 minus P binom. Here you just do P binom 11 comma 15 comma 0.5. Lower tail false because you still have a greater than sign. Lower dot tail is equal to false. Let's see what we get. So yeah, 11 comma 15, 0.5, lower tail is equal to false. So we get 0.0175783.
Ma'am, in type 1 error also, we have to put the lower dot tail
Okay.
equals to false.
Yes.
So, ma'am, when we are doing 1 minus p norms, it also reflect that we are doing the lower dot tail equals to false.
Yeah, you can either do it like 1 minus p binom. You can see this, right? You can either do
Mm.
this or you can just do.
Ma'am, when we do 1 minus p binom, then it is not mandatory that we have to put that lower dot tail equals to false. It by default it take lower dot tail equals to true, and when we are doing 1 minus p binoms.
Yeah, when you don't write anything, by default it's lower tail
Mm,
true. But
true,
yeah,
yes.
so this scenario you can either do this way or you can just do it this way. Like don't specify anything, you
No,
just do
no.
it.
My question is that when we are using the first
Hmm.
way that 1 minus p binoms
Yeah, you're
lower
just
dot tail, we have to put here the value true here, no?
no, you should.
It because when we are doing 1
Hmm.
minus
Hmm.
uh, the value coming up with the 1 minus is equals to the p binoms uh, lower dot tail equals to false,
Hmm.
means the value 1 minus p binoms lower dot tail equals to true, it is equals to the p binomials lower dot tail equals to false.
Oh,
This
wait,
is
we can check that as well. So here in this
because
case, you do lower tail is equal to true, you get 0.35. But
okay.
do the same thing. You just do 1 minus this with lower tail true. You'll get a
Yes,
different,
yes. This is
yeah,
the question.
you'll get a different answer. So
Hmm.
you have to write lower tail false here. Like if you write 1 minus p by now.
So uh,
Yeah, wait.
this is the value.
Hmm.
This is the value of if we are not doing one minus, we can also do in a way that p binomes uh, lower dot tail equals to true.
Yes, that's this one that I'm highlighting, line number 5. You can do this way. So you can see if I run this, you
Mm-hmm.
get 0.35.
Right,
That is
right.
our answer. And even if
Hmm.
you run the first thing, line 4, if I run also, I get 0.35. So
Okay, so both the
yeah,
commands.
both of these are correct. But if you do this, it will be wrong. Yeah,
Okay.
to easily like understand how, you just need to look at this 1 second. So here you have less than sign, less than equal to. So this
Hmm.
is basically a lower tail true. But because there's
Yes.
equal to sign, you can't write that because there's still 11. You have to
Hmm.
change your test stats to something else. So just to make it easier, you're reversing this. So P of t less than equal to 11 can be just written as 1 minus P of t greater than 11.
Okay,
And
okay. So
here
for
within this,
greater than
yeah.
equal. Okay.
So yeah,
Uh,
now, so how do you decide when to specify lower tail or not? You
mhm.
do this 1 minus, that is separate, that is taken care of. Now you just look at this term. So within this term,
Yes.
you have t less than 11, it is lower tail
Yes.
true, default thing. But if you have t greater than 11, you write lower tail false. Anywhere that you have
Yes.
greater,
Yes.
you write false.
Okay.
Yeah, that's how.
So for type 1 error, we have to follow 1 minus p binomes lower dot tail equals to false. And for
Hmm.
type 2 error, we have to follow p binomes lower dot tail equals to false.
No, not necessarily. So this here we are doing this because in your
Hmm.
question, your null hypothesis is t greater than 11. But if your
Hmm.
null hypothesis was t less than 11, then your
Hmm.
type 1 error would just be like if you're, if, let's say it was the other way around. Um, this thing just keeps going to the, oh, that slide. Okay, let me just,
Because in the assignment we have given the question the trail is greater than uh, some value,
yes.
greater than t is greater than some value. So how we proceed in that?
Am I writing the correct? No, I wrote, yeah, wait. We have two scenarios. What am I writing? Statistic hypothesis t. In the question, t greater than 11 is given. So this is our current scenario. We have
Hmm.
this. So in this case, we do like type 1 error. We do 1 minus p binom, like 1 minus probability of t less, I got confused. We had, yeah, 1 minus probability t greater than 11. Type 2, we just had probability of t greater than 11. But in this case, your type 1 error would be probability or what is type 1 error? You reject H naught when H naught is true. So it means you accept H1. So probability t greater than equal to 11 given some probability value. So this, it's easier to calculate this, right? So you can just directly But when this greater than equal to, you can't use that. Mm, you can
But
just write
please
directly
explain
as I know.
opposite scenario also so that I can have a better
Yeah,
understanding
this is
of
the
this.
opposite scenario. This is the
Mhm.
other scenario. So, in your given question, like, is this how the sign is? Or is it just like greater than 11 for alternate hypothesis?
We have given trail greater than equals to some value.
Yeah, I can just check the question. Which question is it? Week
Ma'am,
12.
second question.
12, question number 2.
Yes, T greater than.
Accept the null hypothesis. Now, this is the exact same thing that example I'm explaining. So even in our question that I just explained now, where is it? So even here we had so even here we have T, your null hypothesis if T is greater than 11. So this is your alternate hypothesis, T greater than 11. In this scenario, your alternate hypothesis H1 is T is greater than 10. Your null hypothesis would be T less than equal to 10. It's the exact same thing like the problem I'm showing. It's just
Okay.
other than 11, you have 10. Yeah, it's just the same way. But yeah, I can just tell you the other scenarios. Why does this keep going? Uh, so yeah, you'll have this other scenario.
Okay.
So here you don't do 1 minus. In this case, you already have greater than. You just do p binom 11, 15. Your probability value, whatever, lower tail is equal to false. Lower tail
Yes.
false because there's a greater than.
Greater than. Okay.
But I am not sure if this still should be 11. Like in here, if you have a greater than, it is 11. But if you have a greater than equal to, I
Hmm.
think you should have 10. Because this value is basically your like in one. Yeah, I can just recheck that. Like, so if you have greater than, it's for sure. You just write like 11 comma 15.
Okay.
If you have greater than equal to, I think you should write like 11 minus 1 here. That'll be the ideal thing. But yeah, you understood, right? Like why we are doing this 1 minus and when we are
Oh,
writing lower and false.
yes, ma'am.
Okay.
Thank you.
My God, this thing. Okay. Okay, suppose we have 70 weighing machines made by a company can work on an average 1800 times. So yeah, we just take like X is the number of times your machine works. So N is given 1800. Your estimated mu is like your null hypothesis is mu is equal to 1600. Your alternate hypothesis is mu is less than 1600 and your significance is 0.05, 5% significance level. So you need to say like what decision do you take? Do you accept H naught? Do you reject H naught? Or like can you not reject H naught? So yeah, it is also given, standard deviation is given. So sigma is known here. So known standard. So whenever sigma is known, you use this normal test statistic, Z statistic. So the formula here would be x bar minus mu by sigma by root n. So this follows a normal 0 comma standard normal distribution under H naught. So what this means is, so for a standard normal distribution, for a one-tailed test, it's a one-tailed test because you just have like one less than sign. Your mu is somewhere like here, and mu less than 1600 is your rejection region. You reject H naught in this region and you accept H1. So the area of this region should be alpha is equal to 0.05. And yeah, so the value here, like this is something you can actually remember. So Z statistic for 0.05 alpha, one-tailed, your value would be minus 1.64. So this value is minus 1.64. So here your Z critical is equal to minus 1.64. So now you calculate Z observed Z value. So how can you calculate this? You just substitute this value. What is X bar? So X bar is 1800. So it works on an average of 1800 times. This is actually X bar. Yeah. X bar minus mu is 1600 divided by sigma is 120 divided by 70 is your N. N is equal to 70. So root 70. So if you calculate this, you should get question number 3. Yeah, 1800 minus 1600. If you run this, you have to get 13. So this value is equal to 13.9. 13.9. So your Z observed value is 13.9. So 13.9 is greater than Z critical. Z critical is minus 0.164. So if Z observed, it falls somewhere here. So this is your acceptance region. So you accept H naught. H naught, you accept H naught. So that is your final decision. So what option do you choose? You accept H naught. So H naught cannot be rejected. So this would be your correct answer. So this is false because you accept H naught. No, this is also false because decision is possible. Data is also adequate. So this is your answer. H naught cannot be rejected because you accept H naught.
Ma'am, if in this question mu value is greater than some value, so we will also follow the same way, or
Yeah,
it
yeah,
has
you
some
just follow the
difference?
same way, but you'll follow a right tail test. So this would be your rejection region.
Means,
Like
ma'am,
you,
here you have the value of critical minus 1.64. So here
in this
is
case,
also
you'll have
change.
critical 1.64.
Hmm. So if we have the mu greater than some value, so it have some difference or
Yeah, even in this scenario, or okay, let's just consider this mu. Let's just
greater
consider
than.
this way. So in that case, you'll have a right tail test because mu should be greater. But here
Hmm.
your Z critical is plus 1.64
Hmm.
and your Z observed will still be the same. It is 13.9. 13.9 will fall somewhere here, right? It will fall in your rejection region. In that case, H naught is rejected. H1 you accept. H1 you
Means
accept. Your mu
in
line.
this
Yeah.
case also the Z observed is still greater because the 13.9 is greater than
Yes.
if get the value of Z critical in positive, still the Z observed value is greater. So again we have the H naught can't be rejected option.
Oh, okay. So here you should not look at like that. It doesn't mean that if Z observed is greater than Z critical,
Hmm.
it
Hmm.
doesn't necessarily mean that you accept H naught. It depends on your area, your shaded area of interest. So let's say this is what if
No,
mu
I'm
is
not getting it.
600, it will be here. Your mu will be here. But your
Hmm.
alternate hypothesis H1 in your other scenario, it says mu is greater than 1600. So this is your alternate hypothesis region, which is your null hypothesis rejection region. So yeah, in that case, if you calculate Z observed, it is falling in this shaded region. So in this case, mu is greater than 1600, it becomes true. So your null alternate hypothesis is true. So null hypothesis is rejected. You accept your alternate hypothesis. I don't know if this is, yeah, I was drawing it here. So in the current question, this is your mu. Mu is equal to 1600 is in this line. But you have to consider alternate hypothesis H1 mu less than 1600. So shaded region is your alternate hypothesis.
That
Yes,
is negative.
H1 acceptance region and H0 rejection region, this one.
Yes,
So
ma'am.
in this case, when you calculate, your Z observed falls in your unshaded acceptance region. So here mu is equal to 16, mu is less than 16,600 becomes false. Your alternate hypothesis is wrong here because your thing falls here.
So we can't, H0 can't be accepted in this
Oh
case.
yeah, sorry, it can't be accepted. It can't be rejected either. Yeah, just my bad.
What it follow? I'm not getting it is still. H0 can't be accepted.
H0, no, it's not H0 can't be accepted. You have to say H0 can't be rejected because if you say H0 cannot be accepted, it means that H0 is rejected and H1 is accepted, right? Option B means H1 is accepted, but that is entirely false. You cannot accept H1 because mu is not less than 1600. So option B may not be true. But in option A means that H0 is not entirely true, but it can't be rejected either. So your null hypothesis holds true, but it's not exactly 1600. So you just have to H0 can't be rejected.
So we go with the solution option A,
Yes.
or the other option like C, D, data is inadequate, or the decision is impossible to take about H0
H0.
because we
Yeah.
still not have the values.
Okay. Just 5% significance. It's not no decision is possible to take. Yeah, I'll just confirm this. Right, no decision. Option C is not true. Date. Mu is equal to 600. But yeah, this thing only talks about your estimated parameter.
Yes, ma'am,
Like,
I'm getting this thing, but
not, I think like option A
still
is the
not
best sense,
get
but
an
yeah,
answer that.
I can still confirm.
Oh,
Yeah, I'll
okay.
just confirm this. What is this question number 3? Okay, I'll just confirm this and get back. I'll put it on the discussion forum. Okay, next question. So here, suppose an engine can pump average 185 liters of water. So here, H0, it's given 185 liters of water per second. You have 5 such pumps. So N is equal to 5. Randomly selected. Your values of X are also given. H0 is this. H1 is mu less than 185. 5% significance. I think it's very similar. No, it's not similar. Here, sigma is unknown. So you can't use your Z statistics. So in this case, you'll use your T statistic, one-tailed T. So you'll have T is equal to X bar minus mu by S by root 10. So X bar you have to calculate from this. You can calculate it with R. Question number 4. Yeah, so this is your X. We run it. X bar is basically your mean of X. So we directly calculate X bar minus mu is 185. It's given. S is your standard deviation of X and divided by square root of N. N is 5. So you just run this. You get 0.067. So T observed, I'm writing it here. T observed is equal to 0.067. So yeah, we need to calculate your T critical. It's less than. So less than. So it's a left-sided test. 185. T critical. How do you calculate T critical? So you have to do a not T test, or T distribution for this is alpha. This is 1 minus alpha. So 1 minus alpha comma n minus 1 degrees of freedom. So like can do this R. So you have to find the point. So this is your point T critical. The point below which your alpha is equal to 0.05. So you do QT 0.05. Degrees of freedom is n minus 1. So 5 minus 1 you have 4. And lower tail is equal to false. Did I do a mistake? I don't know. No, you should not write lower tail is equal to false.
Yes, ma'am, it is true here.
It is true because it's a left-sided tail test. You just write this. So your T critical would be minus 2.13. Let me get my slide. Let me calculate. Okay. So T critical is equal to minus 2.13. So this is minus 2.13. So your T observation is 0.067. So it falls somewhere here. So here you cannot reject H naught. So even here is the same kind of scenario. You cannot reject H naught. Yeah, I'll just check this. No decision possible about H naught. But yeah, whenever you see this kind of a thing, this is the option that you should choose. I'll still confirm and tell, but yeah, that's how it is. Is that okay? Okay. The next question, a housing society claims that mean water usage of a home, usage in homes 350 liters in a day. To verify this claim, 20 randomly selected flats were instigated with the result that average daily water uses of these 20 flats are given. What is the T statistics and decision about null hypothesis at 5% level of significance? So here n is equal to 20. Your X bar is, no, sorry, not X bar. Your X bar you have to calculate with R. and your mu is 350 liters. X bar can be calculated. Question number 5, right? So mean of X is X bar. So X bar is 353.8. X bar is 353.8. 353.8. What else do we have? Here, degrees of freedom would be n minus 1. N minus 1 is equal to 19 degrees of freedom. Okay, so the formula here would be you have to do a t statistic, same formula as before, x bar minus mu by s by root n. So s can also be calculated with r. You can just directly do an SD of x. So what is s? So s is 21.847. Yeah, so anyway, you just substitute all these like in the formula x bar minus mu by s by root n. You do this, you get 0.77. So T observed is equal to 0.777. Okay, now we have to calculate T critical. So for that, we just understand by doing a table. So here they're not talking about whether mu is greater than 350 or mu is less than 350. They haven't mentioned anything about that. They just said like expected mean is 350. So your null hypothesis is like mu is equal to 350. Alternate hypothesis is mu is greater than 350 or mu is less than 350. It could be anything. So in this case, like when you have this kind of a scenario, you do a two-tailed test. So alpha by 2 is equal to 0.025 because 5% level significance. So even here also you have alpha by 2. T test. Okay, so how do you do a T? So even here you do T, that QT, because alpha by 2 you have 0.025, degree of freedom 19. Here I think, yeah, even if you write lower tail true or false, you'll still get the same, like plus or minus value. So yeah, you'll get, like if you write lower tail is equal to true, like default, you'll have minus 2.093, like you can see here. And the other thing is plus 2.093. So it's basically like mod T critical, right? So mine, because it's a two-tailed test. Okay, so anyway, we have 0.77. So 0.77 will fall somewhere here. So it is falling in the acceptance region. So you accept the null hypothesis. But we have to calculate the T statistic. Oh yeah, we just calculated, right? 0.77 is your value of T. So option B should be your answer. Yep. Is this okay? So I think, yeah, like you just don't have to worry about like accept it. So if basically the T observed, like whatever observed value that you calculate, it falls in the acceptance region, you just say you accept the null hypothesis or you cannot reject the null hypothesis. So yeah, based on all these questions that
The critical value is given in the exam, or because we
yeah,
have.
it should be given in the exam. So basically for your exam, you won't be having access to R, and
Hmm.
you won't have any like online links as well, like the normal distribution. We use some
Correct,
online
correct,
links, right? You won't have that
correct.
either. And you also won't be given the table. You'll just be given the value that you need to look up in the table. So yeah,
No,
in this
for
case,
such questions we have provided with the values.
yes, you'll be given these values.
Okay.
So all these values that you need to look at the table, or you need to do this QT, P norm, all that values, it should be given to you.
Okay.
Yeah. Question number 6. Okay, a housing society claims that 12 flats. Here n is equal to 12. 12 flats were selected and their electricity usage per week was observed. This is just 12 bulbs. This is not like actual data, it's just the number. This is your actual data. So this is your x. Like in R, you can find mean of x, SD of x. Yeah, anyway, what should we do? Again, here we should find the t statistic and decision. So basically the same kind of a thing you have to do. So uh, society claims that average electricity is at least 40 units per week. So H naught mu greater than equal to 40. So alternate hypothesis is mu less than 40. Now what do we do with this? We compute t statistic, t observed, x bar minus mu by s by root n. So with R, let us do it. I have all this here. You can see my R thing, right? Yeah. You do this. So T observed is um, wait a second. Mean minus 40. So this is giving me minus 3.44477. And what was at T critical? It was minus 2 point something, right? Yeah, if you can draw it, is at least less than 40 is your reject. Yeah, so it's a left-sided. Oh, I'm drawing it here. It's a left-sided thing. So your T critical is minus 2 point, what was it? 093? Yeah, 2.093. And your T observed is minus 3. So minus 3, basically it falls here somewhere. Like here 0. So you'll have minus 1, here minus 2, minus 3, minus 5, minus 10, and so on. So minus 3, T observed, it falls in your rejection region. So what do you do? Here you reject your null hypothesis. Sorry, you reject your alternate hypothesis. I've done the other way around. So here they claim. So whenever they say a society claims its average thing, that means that is your alternate hypothesis. So H1 is greater than equal to 40, H naught is less than equal to 40. So this is H1, this is H naught. So this is basically your H1 rejection region. So you're rejecting alternate your hypothesis. You're rejecting it, and your statistic was minus 3.4. So option C would be your answer here. Is that okay? Did I confuse you? Was that fine?
Yes, ma'am, please proceed.
Uh, Question number 7. Okay. So here, 2 new methods for producing LED bulbs have been proposed. To ascertain which is superior, LED bulb manufacturer produces a sample of 10 LED bulbs. So N is equal to 10. using the first method. So N1 is equal to 10. And using the second method, he produces 8 bulbs. So N2 is equal to 8. So the first set is to be tested in location A, second test is location B. It is known from past experience that lifetime of bulb that is tested is normally distributed with mean and variance. It is known that the lifetimes of bulb. Okay, so standard deviation of A is also given 4000. So sigma square A would be 4000 square. Sigma B square is also given 6000. Sorry. Mm, yeah, just give me a minute. I have to. Ow. Okay, we were here. So sigma n NA is equal to 10, NB is equal to 8, sigma A square is equal to 4000 square, sigma B square is equal to 6000 square. If the manufacturer is interested in testing the hypothesis that there is no difference. So H naught is mu1 minus mu2 is equal to 0, no difference. And the alternate hypothesis would be mu1 minus mu2 is not equal to 0. Okay. No observable difference produced by either method. What is the value of test statistic and conclusion drawn at 5% significance level? Okay. So here we have two sample scenario. And these are independent. These are independent. Bulb A, it has some separate thing. Bulb B. So the lifetime of bulb A will not have any effect on lifetime of bulb B. So they are independent. So this is two sample independent. Okay, in that case, we would have a T statistic. Okay, we'll have a T statistic with the formula X A bar minus X B bar minus mu A minus, no, mu, yeah. Yeah, mu A minus mu B divided by square root of sigma A square by N1 plus sigma B square by N2. So we know all these values. So null hypothesis is that this is 0, right? So you ignore this part. You just calculate like this x a bar minus x b bar divided by root of sigma square A by N. So yeah, we'll just do that in R. How do we get it? Question number 7. So we have A, we have B, we calculate T observed. So whatever this value we get, that is T observed. What is T observed? We get 0.00065. So T observed, we get 0.00065. And now we need to calculate T critical. So like this is a two sample, two tail. 0.025, 0.025. How do you calculate T? You have to calculate QT. No, it's a normal distribution, right? So you do this. No, I think I'm doing a mistake. Yeah, just ignore this part. Wait. So we're calculating a t statistic here. So for t statistic, you'll have 1.96 minus 1.96. These are some things you can actually remember. So this is your critical value. So modulus of T critical is equal to 1.96. So this 0.00, it falls. So this is mu is equal to 0. 0.006, it falls somewhere here, right? It falls in your acceptance region. So accept H naught. What was H naught? H naught was mu1 minus mu2 is equal to 0. So it is very close to 0, right? Like you can see. So you accept H naught in this scenario. What? Okay, let us. So you accept the null hypothesis. What is the value of T statistic? We haven't calculated that. So how do you calculate that? T test. Alternative two-sided. Yeah, this should give you the answer. Mm, 0.97. There's something wrong with this. Yeah, I think I've done some mistake. I'm not getting any of these values. I think the options, did I copy? I think I must have copied the answer for something else. Let me just check. Zero six five. This is what I did, but I didn't get 0.065. But I think I've done some mistake in this calculation. I think 0.006. Square root of sigma a square divided by n1 plus sigma square divided by n2, which is 8. And this seems correct. Let's calculate just one at a time, maybe. What is mean A minus mean B? X A bar minus X B bar is equal to 1.625. 1.625 divided by square root of sigma A square. 4,000 square divided by 10 plus 6,000 square divided by 8. 4,000 divided by 10. SQRT of, no, wait. less 6,000 square. Divided by 8. Square root of this 2469. I'm still getting 0.0065. Okay, they're doing 100 into. Okay, what is the question? They're multiplying it by 100. Why are we doing that? 6, 7. Number of hours. Okay, so what they've done here is they're just multiplying our answer by 100. So we got T observed is equal to 0.00065. 0.00065. So multiplying this by 100, you get 0.0658. So option D is the answer. But why are they converting it? Yeah, I'm not sure why they're multiplying it by 100. But yeah, this is the answer. So if you see, if there's some discrepancy like that, you just see what value this is closest to, like 0.0065. So this would be your answer, closest answer. Yeah, this looks like something wrong with the question. Because here, if you can see, they've multiplied 100. And there's no reason why they've done that. Percentage. It's like all the units are given in hours. So I'm not sure why they multiplied by 100. But yeah, this is how you go about
The question,
kind of a
the
problem.
values.
Sorry?
It is written in the question that the values are given matlab, in terms of hundreds, like
Where
61.1
did I
into
miss it?
100. Some last line,
Okay, okay. Here it's written
100 of hours.
data
Yes.
about the number of hours into 100. Okay, that's why you're multiplying the whole answer into 100. Okay, yeah, I missed this. Yeah. So yeah, in that case, it's clear. The option D is your answer. Question number 8. I think this is also this exact same question, but probably. What is it here? Are normal with equal standard deviation, which is unknown. So here they have mentioned a line about the standard deviation. Yeah, I'm sorry, it just keeps. Yeah, so in this question, they've given a line about standard deviation. So they have same variance. Equal standard deviation, which is unknown. So in that case, you have to use a formula, like it was all given in the table, like this scenario. Should I use a new one? Okay, it's okay. I'll just write it. T is equal to XA bar minus XB bar minus, like ideally you want mu minus mu 2 is 0. So you consider this 0 divided by square root of n1 minus 1 S1 square plus N2 minus 1 S2 square divided by N1 plus N2 minus 2. So I think it's all the same. Yeah, so N1 is equal to 10. All those values are the same. We just need to like substitute all this. Here also it's given hundreds of hours. Okay. Question number 8. So yeah, let's just multiply this into 100. Oh, what did I do? Oh, so sorry. 100 into the list, 100 into. So this is your formula, like mean A minus mean B divided by square root of N1 minus 1. So it is 10 minus 1, 9 into S square, S1 square. So variance of A plus N2 minus 1, 8 minus 1, 7. Variance of B divided by 10 plus 8 minus 2, N1 plus N2 minus 2. So if you run this, you get 0.4876. 0.4876. So your T critical, like you have to do QT because it's a two till test, it's 0.025. And degrees of freedom, you calculated like 10 plus 8 minus 2. N1 plus N2 minus 2. So you get 16. And yeah, this doesn't matter because so your critical value would be modulus, like mod T critical would be 2.11905. 2.11905. Like to be clear, this is minus 2.11. This is plus 2.11. This is your 0. And T observed falls 0.48. It is again falling here. Okay, but that is not the question. So yeah, but if you look at this, what do? You accept H naught. And one more way, so one way is by calculating T observed and comparing it with T critical. You can say whether you want to accept or reject H naught. The other way is to calculate your P value, which is your alpha. So if alpha is less than 0.05, reject H naught. If alpha is greater than 0.05, accept H naught. So you can see that in all these cases, your P value alpha is greater than 0.05. So we just need to calculate the value of the T statistics. Okay, 0. Question number 8. If I do this, see, you can see a T statistic here, 0.97. So this is your T statistic, 0.97. And P value, like you can see in the question, you get 0.348. So option C or D, 0.348. And you had positive, 0.978. T statistic 0.78. Yeah, so this would, option D would be your answer. Is that okay? Okay, moving on to the next question. Random selection of 12 patients, n is equal to 12, were given tablets containing 1 gram of medicine. Another group consisting of 10 volunteers was given placebo tablets that looked and tasted exactly the same as the medicine. So placebo tablets is basically just a medicine that does nothing. But the patients are just made to feel that it is the actual medicine. But yeah, anyway. So it's just like two different groups, medicine and placebo, that looked into. So this was continued for each volunteer until a doctor who did not know if the volunteer was receiving the medicine or placebo decided the volunteer was no longer suffering from the disease. The length of time of disease was recorded at the end of this experiment. This data conducting the t-test of hypothesis to test if medicine is more effective than placebo, the corresponding value of statistic. So your alternate hypothesis, you're testing whether there is some difference between this and this. So your null hypothesis would be there is no difference. So if there's no difference, these would be equal to 0. And if there is some difference, I don't know, d less than 0 could be greater. Yeah, it could be greater than, or it could be greater than 0, like if there's a difference between. What else do we need? I'm sorry. Yeah, these are different sizes, right? 12 and 10. So these are independent. You cannot do this. So you might have to use, if we go back to our table, so if you have dependent samples, you use this formula. If you have independent samples, this is unpooled variance, I guess. So yeah, you'll use this formula, the last one that's given here. There's nothing here given about the variance, so it's probably unpooled variance. And you have two independent samples, populations. So you use this formula. X bar minus x2, s1. So yeah, you have all these values, right? You just substitute this in R. This is question number 9. So we have medicine, we have placebo, and yeah, you do x1 bar minus x2 bar divided by square root of s1 square by n1 plus s2 square by n2, right? This formula here. You run this, you are getting, okay, observed value 0.885. I don't know what this is. Okay. Okay, what is the question anyway? 3, 4, 5, 6, 7, 8, 9. Okay, you need to calculate the t statistic and the p-value and accept or reject. Okay. Do tail again, because it can be either greater than or less than the difference. Two-sided t we just saw something like 1.9, right? 1.9. So t observed, you're getting minus 0.88 something. So that will still fall in your acceptance region. But yeah, we need this t value. Let's just do this t-test NP alternative. Okay, you're getting the values here. So these, whichever, t is minus 0.876, p-value 8052. So if p-value is greater than alpha, you accept the null hypothesis. So option B is your answer here. Okay. Yeah, so this is your answer. Yeah, you just need to make sure what formula you apply. So in this case, you just apply x1 bar minus x2 bar divided by square root of s1 square by n1 plus s2 square by n2. Because these are two sample independent unpooled variance. Okay. Okay, next question is this is also like very similar to the previous one, except that I think this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, this is two sample dependent. Because before and after, they're talking about the same machine, 1, 2, 3 to 10, and before value, after value. So these are dependent samples. So in this case, you would be using this formula. T is equal to D bar by standard deviation divided by root 10. So what is this D bar? You just subtract each of these values from each other. Okay, I'll show that in our question number 10. Okay, so we have before, we have after. So difference is basically after minus before. So you run it. Let's see, you can see the differences. And now you for D bar, you need to calculate mean of the differences. So mean of D would be a D bar. Mean of D. Minus 2.15 is your mean. So anyway, directly substituting it, D bar divided by square root of variance of D, your S square, or yeah, divided by N. Or you can also write it as mean of D divided by S standard deviation of D divided by square root of N, which is 10. Okay. So either way, you'll get the same answer. Okay, we run this. We are getting T observed is equal to minus 2.2659. Okay, anyway, we just have to calculate the T statistic here. So you do this T test. Alternative is two-sided because the difference could be either. It's a paired T test, so true. And your mu, the difference is 0. You do after minus before. So what do you get? You get P value 0.04, T value minus 2.26. So looking at these options, T minus 2.26, P value 0.04. If P value is less than alpha, you reject the null hypothesis. Why are these the same? Both of these options are the same. I think I just did a printing mistake. So yeah, either like you reject the null hypothesis and this is your answer. Okay. Okay, so here the outcome, you might get this type of questions in your exam. You won't be given access to R, but yeah, these type of questions you can expect. So the outcome of a test hypothesis conducted in R is as follows. The related level of significance and decision about the null hypothesis. Question number 11. So by level of significance, I don't see the so yeah, it's mentioned 99% confidence interval. So your level of significance is basically 1%. So 1 minus alpha is this. So yeah, alpha is like 1%. So level of significance is 1%. And decision accept null hypothesis. So you can cross check it using the p-value. So if p-value is greater than 0.05, you accept the null hypothesis. So option B is your answer. Question number 12. It's also same thing. Similar thing. Dependent. Which of the following is true? The test is a T, so it's a paired T test. True difference in means is not equal to 0. So they're calculating difference in means. Look at the brief. Yeah, I'm sorry about this. It just keeps greater than 0. It's not equal to 0. So they're talking about equality of means. And yeah, because you're calculating the difference, it's a 2 sample thing for sure. So 2 sample. And they're most likely because they're calculating the difference, that is possible only when you have 2 dependent samples. So do we have the option? Yeah, we have option D. So the test statistic is 2 dependent samples. Test about the equality of means from a normal population with unknown variance. Nothing is said about the variance. So yeah, option D is the answer. So how you can tell this is based on this line, alternate hypothesis. True difference in means is not equal to 0. Okay, next question. I think here it's going to test. Machine is automatically fills the juice and recently been installed. The machine will be judged to be effective if the standard deviation of the amount of juice in a 200 milliliter glass is less than 0.15. So this is what you want to believe in, your alternate hypothesis. You have a sample of 20 glasses, n is equal to 20, yields a sample variance of it's a sample variance of 0.025 ml. You want to know the machine is ineffective. Value of chi-square statistics, it's p-valent decision about null hypothesis. You want to calculate that. So for such test, you calculate T is equal to n minus 1 into S square divided by sigma square. So if your alternate hypothesis is this, your null hypothesis would be sigma is equal to 0.15. Okay, what is n? N minus 1 is 19. S square sample variance is given. So S square is given 0.025 and sigma square is 0.15. So if you substitute all these, what question is this? Question number 13. If you substitute these, you should get 21. You got 21.111. This is your T observed. And now T critical. So now T critical, you want to calculate for a chi-square distribution. Chi-square distribution 1 minus alpha, n minus 1 degrees of freedom. So 5% significance alpha. So chi-square 95.95, comma 9 n minus 1 degrees of freedom. 19 degrees of freedom. So yeah, this is how you do it. Q chi 0.05. This is your alpha. And 19. Oh, okay. So if you want to perform this, you have to load a library. And you have to just do this. You have to load a library. And then Q chi. So your critical chi-square, T critical would be 3.18. So chi-square is asymmetric, something like that. Minus 3.18, 3.18. So 21, it falls somewhere in this region. So do we want? I think I'm doing something wrong. Not sure. Objective T observe is less. Yeah, I'm not sure if I'm doing this right. I'll confirm this later, but let's try doing. Okay, I'm not sure about this. Yeah, I'll get back to you. I'll confirm question number 13. I'll get back. Okay, let's just go to the question number 14. So there are two different choices of vending machines to test whether the variance of the bottle is the same. You have to test if variance 1 is equal to variance 2. So for test for variance, if you remember, we saw so testing hypothesis for difference of variances, you use this formula. Fc is equal to 1 by m minus 1 divided by 1 by n minus 1 summation xi minus x bar the whole square divided by summation yi minus y bar the whole square. Okay, so this question is something based on that. So sample variance is 0.14. It's given that 0.14, and for machine 2, it's 0.28. So if you do this, you'll get 0.14 divided by 0.28 is 0.5. Yeah, 0.5. So F is equal to 0.5. And now you want to know if you want to reject or accept it. So for this, you do an F statistic. Yeah, let me just draw it out for you. So this is also not symmetric, basically. So it's a two-tailed thing. 0.025, 0.025. So let's just calculate the T critical, like this value. So for that, you do QF, quantile of F, 0.025, n minus 1. What is this, 11? Okay, so P, this is your area, you want 0.025, and DF1 and DF2. So you had 10 and 12, right? So N1 was 10, N2 was 12. So N minus 1 is 9, 12 minus 1 is 11. So that's how you do it. So you get your value 0.255. So this is your 0.025. Oh, no, sorry, what was it? 0.255. 0.255. and you want to calculate the other limit as well. So for that, you do lower tail is equal to false. You get 3.58. So this value here is 3.58. And 0.5 is your T up, like F observed value. So F observed 0.5, this is 0. 0.5 would fall somewhere here. So it is falling in the acceptance region. So this would be your answer. Option A would be your answer. F is equal to 0.5. Null hypothesis of equivalence cannot be rejected. Okay, yeah. And final question.
Can you show the answer of previous question? 13 question 13.
Yeah. This
Question number 13.
13, yeah, I'll get back to you. I'm not sure about that.
Okay, ma'am.
I think I'm doing some mistake. 3.18, 21.11. QF. Yeah, I'm not sure what command to use there. Okay, anyway, the final question. Random samples. This is also something same, testing for differences in variance. I think you have the same question as one of the previous questions, medicine and placebo. And to do that with R, you can do something called variance test. Like whatever we saw in the previous example, the same formula. You apply the same formula, you do it with R, you can do it like this. So basically what we are saying is conduct the test of hypothesis to test if variance of medicine is more than variance of placebo. So this is what they want to test. So they have a greater than sign. So this is H1, H0, so it's greater than. So that's why in R, your alternate hypothesis is greater. So you write that. And 5% level significance. So your confidence interval is 0.95. And you have medicine placebo, like two values. So you do this and you get your F statistic value, 1.158. You get it here. And P value is 0.4217. And if a P value is greater than 0.05, you accept your null hypothesis, right? So you reject your alternate hypothesis. So option A is your correct answer here. Like alpha is greater than 0.05. So accept H0, reject H1. So that's why you have this. Yeah, this is the answer to this question. Yeah, so that's all. And yeah, just so when is your exam again? It's not on 18th, right?
It is not confirmed yet. We have not
But you still
given
have time.
date. Yes,
So is it
we are
okay?
supposed to it is supposed to be on 19 or 26, but it is not yet confirmed.
Okay. 19 or 26? I think,
26.
but usually you should get your admit card 10 days before your exam. So it's
Yes.
probably on 26th if you haven't got.
Yeah.
Yeah. So there's one more extra session. It is supposed to be scheduled tomorrow, but I'm not sure if I can do it tomorrow. So will it be
Ma'am,
okay?
we have provided the link to 6 to 7 p.m.
Yeah,
or
yeah, yeah.
6:30 to 8:30.
So my
So
session is 6 to 7 p.m.
6
But
to
yeah, 6 to 7.
6 to 7. Okay.
So yeah, I just wanted to ask if we can have it some other day, maybe like day after tomorrow, because I'm not sure if I can do that tomorrow.
Ma'am, we will be okay, but until the date is not confirmed, if if the exam date is on 26th, then we will
Yeah,
be
that's okay.
okay.
Yeah, I can
And
maybe let you know tomorrow. Like I can still log in and just
okay.
I'll try to prepare as much. And yeah, so today is your last live session summary. Otherwise, I don't know what's happening to my laptop. Just a minute. Okay. Yeah, so yeah, I just wanted to ask, like, are any of you from a biotech background? BTech.
BTech, yes, ma'am.
So what are you doing? What course are you doing?
No, ma'am, I'm from mechanical background.
Okay, so there's nobody from biotechnology background.
No,
Okay.
I'm not.
Okay. Mhm. Yeah, no, I just wanted to ask, like, I wanted to conduct some online workshops. So yeah, if any of you are interested, I thought you could join, like if you were interested. Yeah, so anyway. But yeah, you can just drop me your email addresses. So in case like some of you had asked to do like more art demonstrations for file handling, like practical applications. So yeah, if you're interested, I can do that with all of you combined.
Ma'am, in chat box.
Yeah, you can just type in the chat box.
Okay. Ma'am, first question from the previous assignment 11.
Oh
Ma'am,
yeah.
you discussed that all estimator are consistent value, but the solution it's something else. Uh,
If there is a bias in your estimator, you have to calculate your MSE.
okay.
So if it's unbiased, like if it's unbiased, your MSE will be equal to your variance. So in that case, only calculating variance is sufficient. But if there is a bias, you have to calculate MSE, which is your variance plus bias.
Okay.
Yeah, I think there was a confusion. Yeah, if anybody else is interested in just additional like other kinds of R sessions, you can just drop your email address.
Hello, ma'am. Am I audible, ma'am?
Yes.
Ma'am, I want to ask a question from week 11. It was first question, and I followed your instructions.
Oh yeah. It looks like if there is a bias in the estimator, you have to calculate MSE. So for unbiased estimators, like variance is equal to MSE. So in that case, calculating variance is sufficient. But if there is a bias, variance is not a sufficient estimator. You have to calculate MSE.
Ma'am, you solved almost exactly that question, but the answer is marked incorrect, ma'am.
Hmm.
Like it has three
Because
mu1, mu2, mu3.
in our previous like lectures, that was the answer. That's how we had discussed it.
Yes,
So
ma'am.
I can just try talking with them, maybe.
Okay, ma'am.
Maybe.
And one more question, like there are three TAs, so we will be giving this NPTEL exams on computer based. So I want to ask, like, who make questions, you guys or some other committee?
No, the three of us who teach, we don't set the questions. So there's another
O-
set of TAs. So only they set the questions. So they are the ones who set your assignment questions as well.
Okay, I asked this question because, like, in the recent weeks there is a more calculation based on the R program. So will the final test follow the same, or it's just normal putting the equations and formulas and values, then calculating.
Yeah, so whenever like all the things that we did with R, it was to calculate based on your tables, right? Like normal distribution, T, F, chi-square.
Yes, ma'am.
In that case, you will be given the value. Like for example, T critical, we calculated T critical for 0.05. So that value will already be given to you in your exam if you're
So
given
it
that.
will be more based on numericals.
Yes, you will have these kinds of problems as well, but just you will be given the value. So you won't have access to R, you won't have access to any online links, and you won't be given tables. So all values would be given. But yeah, you'll have an online you'll just have a calculator. So all numerical problems you'll be given. And maybe you'll have like screenshots of some R related uh, codes, and the questions could be based on that.
Okay. Okay, ma'am.
Okay.
And also, ma'am, if you could really ask this question from week 11, it will be very helpful because
Okay.
it's the only question that marked incorrect. And if
Okay.
it get corrected, I will get 100 marks.
Okay. Okay, I can just ask that. Okay, question number 1. Okay. Yeah, I'll let you know tomorrow about the extra session where we discuss the things that were not clear. Yeah, I've made a note of that.
Will you be taking tomorrow's class also?
I am not sure if I can do that tomorrow. I'll let you know tomorrow. But yeah, it looks
Because
like
in our announcement, there are
yeah,
two sessions
I just saw
already
it.
allotted.
Yeah. So 6 to 7 is supposed to be my session.
Okay.
That two links were given. Session 1, I
So
think
that
7.
session will cover entire course.
Not the entire course. I'll just discuss like some of you had like didn't some of you wanted more clarity with respect to some problems. So I might just try to cover those. Like if you have any particular problem, I could discuss that as well.
From any week.
Yes.
Ma'am, other than that, if someone has any doubt,
Mm.
can we approach you?
Yes. Yeah. You can put it on the
Provide
discussion.
us the
I will keep
okay.
trying to update. Yeah, I'll try to be active on the discussion forum from now because there's no more classes. So
Okay. Thank you, ma'am.
okay. All right. I'll let you know tomorrow. Otherwise, yeah, see you. Kalayoni.
Ma'am, if possible, can you please upload this video on YouTube uh, before early morning because tomorrow is the last day, and if we want to solve more questions, then we have to complete this week by tomorrow itself.
Yes,
Okay,
ma'am.
I'll try to
It's a
upload it now. Yeah.
please upload it
Yeah.
today itself. It is
Okay,
possible
yeah,
for you.
I'll try to do that.
Okay, thank you.
Okay. All right then.
Thank you, ma'am.
Thank you. Yeah, good night.